Hello guys, welcome once more to Prepclass Physics class online, and my name is Dr. Dami. We shall be looking in this edition at Jamb Physics 2018, question number 11 to number 15, and we shall be destroying Jamb. Now, don't forget that if you learn anything from this video, to click on the like button. We have loads of content to send to you that will better help you understand physics. This edition, we shall be looking at some problematic aspects of physics that you will be that will be clarified, and then you will become master of it. Now let's check out number 11. Number 11 says what type of reaction is represented by the following scheme? We have X, Y producing Z. That means there's an arrow. There's supposed to be an arrow in between this. There's supposed to be an arrow here. It's a reaction, right? So X plus Y, two reactants producing 1, produce Z. Then we have extra, we have 1, 0, and we have energy. Actually, this N is a neutron. It produces 1 more neutron, but the main guy here is Z. So the main guy on the product side is this Z produced. Then we have 1 neutron and we have electron, right? Now, is this fission, chain, radioactive, decay? Do you have any idea which one might be correct? Now, actually, the answer is fusion, and I'll tell you why. Fusion is a reaction that has to do with two nuclei forming 1. Now, in this case, you have Z and Y forming Z, and that's why it is fusion. When you have, it's like you have two nuclei, 2 stones. Like I have 2 stones. When they come together and they form 1, that 1 will be stronger or massive. Then what this cartoon is for? Voltron, okay? Or you've been watching Power Ranger. They come together to form 1, right? Now, when they come together, they become stronger. That is an example of fusion. So when nucleus or nuclei, that's plural, when nuclei fuse into 1, that fusing is called fusion reaction. Okay, and that one absorb energy. Okay, in that process it becomes very strong and it takes in energy. But fission has to do with one splitting into many. Okay, in fission, a single one splits into many. So, and that one that I'm talking about is nucleus. When one nucleus splits into many, you have fission. So fission breaks down, while fusion forms together. It fuses, and that means fusion is the opposite of fission. Okay, but they are never the same. Fission breaks down and they release energy, and fission is the secret of bomb making. In a bomb, it breaks down. That means one bomb breaks into many forms. It explodes, and then in the process, energy is poured out. That's why in the movie, if you see, when bomb explodes, people are thrown away because energy is released in fission. Fission releases energy, okay, while fusion absorbs energy because it forms 1. The energy enters that core. Then we have chain reaction. Chain reaction has to do with it's a part of fission. When you have 1 breaking into many, right? When 1 breaks into 2 and 2 breaks, that 2, each of them breaks into 2 more. That's 2 breaks into 4, and 4 breaks into 8. It is forming a chain, right? That chain, it keeps breaking into 2 more. It's expanding. That's an example of chain reaction. So chain reaction is under fission. Then we have radioactive decay. But the answer to that question is simply fusion reaction. 2 fuses into 1. That's X and Y fuses into Z, and that is the answer for that question. Let's check out that makes option A the correct answer for number 11. Let's check out number 12 now. The amount of heat needed to raise the temperature of 10 kilograms of copper by 1 Kelvin is its what? Do you have any idea? Is it specific heat capacity, latent heat capacity, or internal energy? Now let's define these guys now. Now, first of all, we have to define what latent is. It is the amount of heat needed to change the state of a body from solid to liquid or liquid to gas. It is the amount of heat that changes things. The heat you need to change something is called latent heat. The word latent actually means hidden, something you can't see. Now, when solid is changing to liquid, like ice is melting, the heat that performs that operation is invisible. What I mean is that on the scale, if you are drawing the scale for the conversion of solid to liquid in the laboratory, if you are drawing the scale, that's the graph. Okay, when solid is changing to liquid, at that point the temperature does not increase. That means when I have my ice, okay, and it's melting to liquid, at the melting point, the temperature of that ice is is not increasing, it remains fixed. And that's what we call latent. It is latent, means you can't really locate it, it is hidden. And then also, when liquid change to gas, the temperature remains the same. That means on the graph, the temperature becomes the same. It does not increase. So that is called latent heat. It is the amount of heat needed to change the state from solid to liquid or liquid to gas. Now let's talk about the next one, heat capacity. Now, because this question says the amount of heat needed to raise the temperature. So latent heat is not changing. So the answer is not latent heat. It is not raising the temperature. It is only keeping it constant. Now, heat capacity is the amount of heat needed to raise the temperature of a body by 1 Kelvin. So the answer is heat capacity. It is needed to raise the temperature of a body. That body can be 10 kilograms, can be 50 kilograms, anybody, whether 20 kilograms, but the amount of heat needed to raise the temperature of a body by 1 Kelvin. Kelvin is the unit of temperature. We all know that, right? So the amount of heat that's needed to raise that temperature is called heat capacity, and that is the answer to the question. Now let us check briefly the others. Internal energy is the energy associated with the random motion of molecules. The energy of a body is called internal energy. It is the amount of mass or heat within the body by the movement of its molecule. That is the internal energy. But that's not what the question is asking, so that's not relevant. Then we have specific heat capacity. Is the amount of heat needed to raise the temperature of 1 kilogram of a body. Now, specific heat capacity and heat capacity are similar. The only difference is that specific is specific. It is the amount of heat needed to raise. It is not to raise the temperature of a body. It is to raise the temperature of 1 kilogram of a body by 1 kilogram. So it is being specific to only 1 kilogram. It can only be used for 1 kilogram, while heat capacity can be used for 10, 20, 30, and so on. So specific is for 1 kilogram of a body, while heat capacity is the answer because it can function with 10 kilograms, 20, 30, etc. Okay, so the answer to that question is the heat capacity is the amount of heat needed to raise the temperature of 10 kilograms of copper by 1 Kelvin. The answer is heat capacity, not specific heat capacity. That's for only 1 kilogram of a body. Now let's check out number 13 now. The electrochemical equivalent of silver is this 0.0012 gram per coulomb. If 36 grams of silver is deposited by electrolysis on a surface by passing a steady current for 5 minutes, the current must be what? Now this question is under electrolysis, right? Now there's one law in electrolysis called the Faraday law of electrolysis. That's the first. There are actually 2 Faraday laws, but we have the first one. The first Faraday law is more emphasized in physics than so it's more emphasized. But in chemistry, you have to deal with questions from both. But physics focus more. I don't know why. Physics focus more on the first law of Faraday, although most parts don't focus on that. And also textbook also focus more on the first law, but chemistry focus on both. So I personally noticed that. So this question is automatically from the first Faraday law of electrolysis. Now let's check it out now. It says Faraday's first law of electrolysis says mass is directly proportional to charge. I just simplify it that way. That is the summary of the law. Okay, now you have mass is directly proportional to Q, right? Charge is Q. Now then we have mass is therefore this directly proportional will become equals to Z, and that Z is the unit of is the electrochemical equivalence. So it's called, you have to change this into mathematical format. Directly proportional must change to equals to Z. The Z came with the equals to, and that is the electrochemical equivalent, and that is it has a constant 0.0012 G per coulomb. It will be given to you always. Now we have my Q, so it is M equals ZQ, right? Now but Q also can be broken down into IT, so my format is now M equals ZIT. I is current and T is time. In science, M is mass, Z is a constant, just this constant, electrochemical equivalent. Then I is current, T is time, and Q is charge. Q is actually charge. Q is actually charge. So we have that now. So M equals ZIT. Q change to IT. So now we have to find the current. That's I. So make I the solution. So it will become I equals M over ZT, right? I just divided both sides by M by ZT because the ZT will go under A. It will go under the M. So M over ZT. So my M is what 36. My Z electrochemical equivalent is 0.0012. My time is 5 minutes, but that's a trap. It must not be in minutes. Time is not measured in minutes in physics. It must be in seconds. So that will become 5 times 60, because 60 seconds make 1 minute, right? So time must be changed into seconds. That's by times it by 60. So I have 36 over 0.0012 times 5 times 60 is 300, and that's what you have. So I have 36 over 0.0012 times 300. That will give me 36 over 0.36, and that's what you get. So that will give me 36 over 0.36 is what 100 ampere, and that is the answer to the question. 100 ampere, and that is the current you will derive from this second, and that means option B is the correct answer. Now don't forget the Faraday law, very important. Once you know it, you can tackle any question on electrolysis in physics, and I tell you that. Okay, so let's get on to number 14. Shadow and ellipse result from the what? Now what forms shadow? Very simple. This is just elementary. It's actually basic 5 questions. Now look at it. The sun shine on the moon and form around the earth. Now if you put now don't forget that if you put like, even if I don't use this as an example, you know, it is during eclipse are formed by shadow. It's a kind of shadow, right? Eclipse will happen at this point because the moon is blocking the sun. The moon is blocking the sun, and when something blocks the light source, there will be shadow, and that's the answer to the question. The answer is simply when there's an obstruction to the path of light, it will cast a shadow. Like if you put the torchlight towards the wall and you block it with something, that thing you block it with is going to cast a shadow on the wall. So shadows are formed when light is traveling straight and something obstructing or blocking, then it will cast shadow behind. And that's what we have here. So the moon is casting the shadow, and the shadow casted by the moon is the reason for eclipse or solar eclipse that we have. When days turn into night, it is caused by the shadow. That means it is caused by the blockage when the moon blocks the sun, and that is what causes solar eclipse. And that's what we have. So the answer to that question is just rectilinear propagation of light. That means when light traveling, the reason for shadow and eclipse is that light is traveling on a straight line, and that's what we call rectilinear propagation of light. That means light is being propagated or made to travel on a straight line, and that is why we have shadow. If light is not traveling straight, there will be no shadow, because if it travels perpendicularly or travels not straight, it won't cast. Nothing can block it if it's not straight. It can only be blocked or obstructed when it is traveling on a straight line, and that's why we have shadow. So it is called by the rectilinear propagation of light, and that's the answer. You can't afford to forget. And let's check out number 15 now. Which of the following obey Ohm's law? Do you have any idea? All metals, diode, or electrolyte, glass. Now actually all metals obey Ohm's law. Ohm's law says that I equals V over R. That's current equals voltage over resistance. Now those that obey Ohm's law are the ones that operate using the principle of Ohm's law. All metals can conduct electricity. You know, Ohm's law is an electrical law. It talks about how electricity is being conducted using this formula. This is Ohm's law here. This is Ohm's law here. Okay. Now all metals can conduct electricity. Okay. So they all obey Ohm's law, right? They all obey Ohm's law because they are all conductors. Now diode does not. Diode is one of those things that do not obey. Diodes do not obey Ohm's law. Then also electrolytes, not all electrolytes. They said all electrolytes. That's very wrong. Some electrolytes can obey Ohm's law, while some cannot. So not all electrolytes can. Okay, but glasses are actually insulators. They have nothing to do with electricity. So therefore, glasses are out. So the only one that obeys Ohm's law are metal. Metals obey Ohm's law, and that's why they are the answer to the question. So the simple answer to the simple question is just option A, and that brings us to the end of this video. Don't forget, if you learned something from this video, to click on like button. We have more content to share with you that will better help you understand physics. Until we see next time, guys, take care of yourself and bye for now.